Okay, so we are solving systems and we're doing 7B. So we're going to be doing the second day of this. Should be a lot easier than the first day, especially since we kind of exposed you to everything already. So let's start off with your learning goals. I can, when given an equation, write a system of equations that will result in one solution, many solutions, or no solutions, and solve a system of equations using any method you choose. I'm only going to show you one. I can show you others in class if you want, but you're pretty much free to choose whatever method you want to solve these. Okay, so let's start off by going through the whole no solution, all infinite solutions or many solutions and one solution thing. So, graphically speaking, systems with no solution do not intersect on a graph, meaning the lines are parallel. The lines don't touch at all, because remember, for there to be a solution there would have to be a point of intersection, and there's not. Notice, like, if you look at this and this, the equations are identical. What's different is what they're equal to. Okay, so like if you were to put these in slope-intercept form, they'd have the exact same slope, but the y-intercept would be different. Same with this. If you rearrange this, you would come up with this, but this number would be different. Okay, moving right along. Systems with infinite solutions, which are also called many solutions. So it could be infinite solutions with many solutions. When you graph the two lines, they will basically overlap the entire time. They will be the same line. So if we look at this, we have this as one system or one equation in a system, and there's the other. If you were to go ahead and try and do elimination on this, say multiplying the top by -2 to get all this to cancel out, what you would end up with is -2x minus 4y minus 10, or equals -10. And when you cancel out your x's, you'd actually end up canceling everything else out and ending up with 0 equals 0. So if you use elimination and you ever do that, you end up with 0 equals 0. That's when you have infinitely many solutions. The other thing you could do is you can look at your equations and say, hey, can this be reduced at all? Meaning, can all these numbers be divided by a number to be reduced? And in this case, yes. 2 goes into all of these. So like 2 would go into 2 once, cancel it out. 2 would go into 4 twice. 2 would go into 10 5 times, giving you the exact same equation. Same thing over here. And in other words, the lines are constantly touching. So y is a solution to a system of equations, a linear pair, meaning the coordinate points. And that's because two lines will cross at one point. So since it's a point, there's an x value, there's a y value. So when you're rewriting an equation to change the number of solutions, you're going to be given one linear equation, and you have to create another one that either makes the system have no solutions or infinite solutions, and then we're going to kind of throw in there also one solution. So when you do this, you want it set in this form. This is called, this form that we're going to be using, we represent it as ax plus by equals c, where a is the coefficient of x, b is the coefficient of y, and c is the constant. So I'm going to refer to things as your a, your b, or your c. That's what I'm talking about. So as far as how to create that second equation, for a system with infinitely many solutions, you want to determine the a, b, and c of the first equation, the one you're given, and then you can find more solutions just by doubling or tripling each of those. So meaning the a, the b, and the c. So if you're going to double everything, multiply a, b, and c all by 2. For a system with no solutions, all you're going to do is change your c value to any other number. And to create a system with one solution, you want to change two values, either your a, your b, or your c, to any other number. So you want to change 2 of them. So for example, if we have 3x plus 4y equals 11, and we want to come up with 3 different linear equations that represent no solution, infinitely many solutions, and one solution, we're going to go ahead and take a look at our a, our b, and our c. Now remember, with no solution, we want to go ahead, there's your a, your b, and your c. So we've got 3, 4, and 11. So sometimes pulling the numbers up make it easier to work with. For no solution, what we're going to do is we're just going to change the c. So I changed the 11 into a 10. Everything else stayed the same. Okay. For infinitely many solutions, I doubled A, B, and C. If I wanted to, I could have tripled it. I could have said I'm going to multiply all of this by 3. So I would have had 9x plus 12y equals 33. That would also give me infinitely many solutions. So there's a lot of different things you could do here. And then for one solution, I made 3x plus 5y equals 15, so I changed the b and the c in it. Pretty simple, pretty straightforward. You could have changed the a and the b, you could have changed the a and the c. Actually, no, you could not have changed the a and the b. Yeah, we'll get into that. Well, no, you could have changed the a and the b. You got to be careful, though. It's better to usually just change the c and then one other thing. All right, so for example 2, we want to solve the following systems of equations. All right, so there's a lot of different ways you could do this. I choose elimination because I think for this type of problem it's the easiest. And the reason why is because you don't have anything that's set equal to just y or x, so substitution is kind of out of the question, especially since every variable has a coefficient. You could graph it. That would require you to put both of these in the slope-intercept form. So if you want to do that, that's entirely up to you. But I chose elimination. And I'm going to go ahead and get rid of the y's. So I took my 3 and my 2. So the 2 I multiplied the top by, and the 3 I multiplied the bottom by. So whatever was on top of the one you want to get rid of, you multiply the entire bottom one by. And since they're both positive, I made one of these negative, because remember, they need to be opposites. Okay, so I went ahead and multiplied negative 2 times 4x to get negative 8x, negative 2 times 3y to get negative 6y, and negative 2 times 265 to get negative 530. And then did the same thing with 3 on the bottom. Now, remember, it's easy to go ahead and put them into the columns. What's going to happen is your negative 6y and your positive 6y are going to cancel out. So that's just, those two would equal 0. So we don't even need to write it. So we just need to do negative 8x plus 9x, which is x, and then negative 530 plus 570, which is 40. Use your calculator here, guys. So then I'm going to take that 40, I'm going to plug it into the first equation. It doesn't matter which one. And I'm going to plug 40 in for x, because x equals 40. So 40 is going to go right there. So 4 times 40 plus 3y equals 265, which gives you 160, plus 3y equals 265. Get that over to the other side, get it away from the y. You have 3y equals 105, and then divide by 3 to get y equals 35. And you have your answer of 40, 35. And as always, you should take these and plug them in for your x and your y up here to make sure that they come out to these answers. And that's all I have for you today. Hopefully it wasn't too long. I know these sections tend to be a little bit longer. It's a lot to take in. So any questions you might have now as we're going through this, I would write down in your notes so you remember to ask them in class tomorrow. Take care, guys.